Hello friends, welcome to follow up. In this video, we are going to look at problem 451, sort characters by frequency. This is a rather straightforward problem, so we can regard this one as a continuation of problem 387. So this problem 387 is today's daily challenge problem. The common part for these two problems in our solution is the use of dictionary. Or in other words, we use dictionary to help solve this problem. Or more general, we use data structure to solve problems. So here we are given a string. We want to sort it in decreasing order based on the frequency of the characters. The frequency of a character is the number of times it appears in a string. This is rather easy to digest or understand. So we want to return the sorted string. And if there are multiple answers, return any of them. It's possible, right? You have some character which appears the same number of times. So for this problem, so you have a tree. So here E appears twice, so we can put it in front. And both R and T appears once, right? So you can organize as RT or TR. Both are okay. So in example 1, both C and A appears twice. So here we have this CCC, AAA, or AAA, CCC. Notice that in this problem, we regard this kind of problem, CA, CA, CA is incorrect, as the same character must be together. So this is actually an additional constraint, right? So if you look at the problem itself, you cannot interpret this one. I guess this is also a small drawback in the statement of this problem, right? Because this A and C, because all the characters in C or A appears same number of times or have the same frequency, essentially this one should be correct, right? But because of the example 2, we need to pay attention to this one, right? So here capital A appears once, little a appears once, and B appears twice. So we have BB in front. But these two A's, you can treat A, capital A, or little a, capital A, right? So the constraints for this problem are the following. First, the length can be up to 5 times 10 to the power 5. So this basically gives us a upper bound for the problem size. And secondly, S consists of uppercase and lowercase English letters and digits. So this actually is not very essential, right? Because we just need to use a dictionary to count the unique characters and their frequencies. And then we can give a customer the sorting key, right? So here we use dictionary to do frequency statistics or counting, right? Then we use sorting key to get the orders, the desired orders, right? So in this regard, this problem is rather straightforward. So here, let me first do a frequency statistics. So we can make a dictionary. So we can use collections counter, right? As we mentioned in the previous video, so this counter S is a dictionary object, which basically gives us the unique characters in S and their corresponding frequencies. So this D will give us information or provide us information for defining the sorting key, right? So now we can first make as a list, right? Because list they have, or you can just sort, right? So then we can do sorted. So after we sort it, we want to pass a sorting key to this function, right? So we can pass the lambda function. So the general object in the list, let's call it say a character, right? And then we want to do the sorting according to their frequency from large to small. So we can use D character, but we put a negative sign. But this is not sufficient. In principle, if we do not look at the example 2, and then we look at the statement, this actually includes all the information for the problem. But here, they want the same character stay together. So in this way, once they are tied in the frequency, right? So I'm going to then sort according to the character itself. So this way, we are going to, you can put even negative character or some negative theme. So basically, or you can put a reverse order. So this way, we are going to sort. For example, here A and C appears both 3 times. Then if we do this, then A will be front. We are going to output this one, right? But you can also design a device to return this one, right? So with that said, so this is the sorted, because sorted will give us a list. You can actually directly do S, right? So once you do this, you are going to get a list. Then you want to return, you need to, because this problem we require to return a string. You can use join method. You have an empty string or separator, right? Something. Then you join this. You are going to get the correct return. So this is what we want to return, right? So this way we write 2 lines of code. Let's do a test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the cases. So as we mentioned in a previous video for problem 387, if you are not very familiar with collections counter objects, you can do a vanilla dictionary. Let me copy this one and also make a remark on using dictionary directly. So here I'm going to mark this one as version v1. So here, let me initialize a dictionary, right? You can initialize like this, or you can do d equals dict, right? Use the class name to initialize. So in this way, we just need to do a for loop. So for character in S, so here we do not need to retrieve the index. We just iterate over the character. Then we get a d character. When we write this expression, we don't know if this character is already in the dictionary. In other words, if it's a valid key or not. So we use a get method. So in this way, we can get the character, the frequency. If the character is not a dictionary key, so we're going to have a default value that for sure is 0. Then we increment by 1. So the by 1 is due to the current occurrence of this or appearance of this character, right? So this way, you will have the same object as this D. Then you can do a test. Let's test directly. Yeah, it passes all the cases. So in this video, I just presented 2 formats of solutions to this problem. So this problem can be solved by a lot of different formats, but you can also think of other ways. But here, we want to demonstrate the use of dictionary as in problem 387. So in the next video, we're going to do a similar problem. So that's basically about it for this one. With that said, I guess, thank you.